lesson, you will solve radical equations and solve radical equations with extraneous solutions. So first of all, what is a radical equation? It is an equation that contains radicals with variables in the radicand. So here's our first example where we have a variable inside the radical, the radicand. Carly and Sam are sailing in Avery's sailboat. They measure the whole speed at 9 nautical miles per hour, find the length of the sailboat's water line, and round to the nearest foot. So we're going to let H be whole and W be water line. So we're trying to solve for what's inside the radical. So we know that H is that whole speed, which is 9 nautical miles per hour, equals 1.34 radical W. Now what we have to do is to get everything away from the radical, and this is a multiplication relationship, so I do inverse operations. The inverse of multiplying is dividing. So I divide both sides by 1.34. When I take 9 divided by 1.34, I get 6.72, and you can check that on your calculator now if you'd like to, is equal to radical W. Those cancel. So when you look at this, in order to get the W by itself, we do the inverse of square rooting, which is squaring. So I'm going to square both sides. When I take 6.72 squared, I get approximately 45.16. I rounded to the nearest 2 decimal places. When I take radical W squared, that's like radical W times radical W. That would just be W. And if you want to work that out slowly, work it out slowly. But anytime you take a radical times itself, it's going to be the radicand, which is what's inside. So the length of the water line, I want to round to the nearest foot. So I'm going to have it be 45 feet. So you try the real world example in your notes. In example 2, I want to get everything away from the radical. Can you see that this add 7 is outside the radical? So the inverse of adding 7 is to subtract 7. So now I'm left with radical A plus 5 is equal to 5. Now remember what we did last time? I now have the radical by itself, so I square both sides. The square of radical A plus 5 is just A plus 5 equals 5 squared, which is 25. Now you just balance like you would any other type of equation. Obviously, the inverse of adding 5 is subtracting 5, and then I have A equals 20. So your solution for A is 20. If you plug it back in, 20 plus 5 is 25. Radical 25 is 5 plus 7, which is 12. So yeah, you know it works. Go ahead and try the example in your notes. Now we're going to talk about what would happen if you have an extraneous solution. That is results that are not solutions to the original equation. And so I'm going to show you an example of one that we're going to have here in example 3. This is already a radical by itself. So we're going to square both sides as our first step. We don't have to get anything away from the radical. So when I do radical k plus 1 squared, that just works out to k plus 1. But when I take k minus 1 squared, what you have to remember is you're taking k minus 1 times another k minus 1. So you can use FOIL, you can use boxes, or if you remember our perfect square, it's going to be the first term squared, and then I take 1 times k, which is negative k, double it, so it's negative 2k plus 1. And you can do the shortcuts like I did, or you can FOIL it out, whichever one is fine. So now when we balance this equation, what we want to do is to try to get all the k's together and solve for k. So if you want to work everything, maybe let's go this direction to keep a positive k squared. So we're going to subtract k, and so I have 1 is equal to k squared minus 3k plus 1, subtract 1, and then I have k squared minus 3k is what I'm left alone with, is equal to 0. This is just like in the couple chapters ago where we set it equal to 0, that's what we just did. Now I look for a common factor that I have here, which is k. So 0 is equal to k, and when I divide both of these by k, I get k minus 3. And then we separate and solve. So I get k is equal to 0, and k minus 3 equals 0. When I add 3, I get k equals 3. Now, when we would solve for parabolas, we would say, okay, both of those are our answers, 0 and 3. But what we have to do for this problem is we have to plug them in and see if they both work. So let's try 0. 0 plus 1 is 1, and the square root of 1 is 1. 0 minus 1 is negative 1. Is 1 equal to negative 1? No. So this is what we call an extraneous solution. It won't work. Now, if this one doesn't work, then you would have an empty set. Nothing works. But we're going to try 3 before we decide if it works or not to see if it works. 3 plus 1 is 4, which is radical 4, which is 2. 3 minus 1 is 2. Is 2 equal to 2? You bet. So my solution is k equals 3. So you try the example in your notes.